Thank you very much, Mark. Hi, Mike.
Hey there. You're all good to go.
Just wait. Here you go. I presume everyone can see my screen?
Yes, we can.
Okay, perfect. Well, thank you very much. Do appreciate being a part of the organization. What I wanted to do is I'm going to spend around 15 minutes just talking through some high-level market and industry trends, and then after that Rajiv is going to follow up with some live examples. And what I'd like to achieve, given the composition of the group, there's seasoned CISOs, there's some folks somewhat new to the security industry, is to just talk about software supply chain risk, what it is, some of the major trends we're seeing, talk about some actionable, simple suggestions around how to remediate a component of this. We are going to discuss free tools that are available that reduce risk and give you significant bang for your buck. And then Rajiv is going to talk about attack surface reduction as his security philosophy, provide some live examples of exploits and show how those can be remediated. So we are going to move relatively quickly. Feel free to reach out to me for the deck and for any clarifying questions. But we've all heard of software supply chain risk in the news, and what is it? There are many definitions, but perhaps the most useful definition is that it's the systemic risk that arises from using software components or applications not developed internally. And the reality is that the majority of software that we use in our business lives is externally developed. Only a small component of it is internally developed, and that's what kind of gives us the fundamental dilemma. And so there's a number of mathematical realities that make defending against software supply chain risk very difficult. The first is that anytime you get a large number of components in a given system, the fact that there's this multiplicative compounding effect means that your average risk of breach is increasing. So assume you had essentially 20 components that were delivering value into your system, and there was only a 2% of breach in the next year, which is relatively low. That suggests you could go 50 years at that current run rate and be breached once in that component. When you compound all of those together, it actually means that there's a 33% chance of breach in this year, and that's very unintuitive in many senses. And we have to remember that this daisy chaining of systems together creates a lot more exposure than one would expect. The next key insight is you're only as strong as your weakest link. And so if you have these same 20 components and 19% are 100% safe, and one of them is 80% safe, that sets the ceiling for your overall risk profile. You can never be stronger than your weakest link. And perhaps the best example of that is if you've got 1,000 employees and all of them are adopting strict security hygiene, and you've just got one of them that is out there doing foolish things, that individual is actually going to set the limit for your overall security. And the third major observation is that software chains are growing and they're elongating this attack surface. There's considerably more software coming into the infrastructure from open source. We're working from home. There's numerous devices. The way we develop software, we use software as a service, infrastructure as a service, platform as a service, third-party APIs, and all of these things you can think of being as components contributing to your overall risk. And a good example of that are cloud vendors, in the sense that a major cloud vendor was recently targeted, and little did we know that even though our infrastructure could theoretically be completely safe, because they were involved or one of the components delivering value, that then translates into exposure for us. So modern software risk arises through a number of mechanisms, but at the end of the day, one of the key insights is that the way we develop software is fundamentally based on trust, in the sense that 90% of the code in a given container is comprised of open source. This is code we didn't write, we didn't vet. Microservices and so forth containerize these, and they pull in a vast amount of code, most of which we're oblivious to and don't know. Historically, we've trusted it. And these are all built and delivered and assembled using DevOps principles, which in many ways make it very easy to incorporate components into systems and very hard to get them out. So open source adoption is growing rapidly. There are a couple of measures, but in terms of open source code, number of new components in the four major ecosystems in Java, JavaScript, Python, and .NET, that's growing at 20% year over year, and the number of components being downloaded is growing exponentially, 70% year over year, and the adoption of open source in modern architectures now is dramatically changed the shape of these risk curves, in the sense that only a few years ago, in 2015, only 36% of the software in a code base was open source. Now that's gone to 75, and it's actually increasing. So attack surfaces are being increased all the time, and there's two sort of vectors of risk. The first is intentional supply chain attacks, and these are examples of malicious actors intentionally inserting artifacts into the software supply chain upstream. And the second is essentially a byproduct or accidental. Code is written, vulnerabilities arise, and it's just a function of the way code is written. But intentional supply chain risks and attacks have been in the news recently, and by any metric, they're growing exponentially, both in terms of the number of exploits. This is from a Sonatype report, and then In-Q-Tel recently put out a report that the count of attacks is going up exponentially. This is 2020. If we were to benchmark 2021, it would be somewhere up here. The three major types are dependency confusion. Essentially, as these software applications are built, when you start pulling in dependencies and packages from the outside, there are ways to actually trick your build processes into incorporating components that you didn't expect and didn't know. And there's a variety of creative mechanisms that are doing that. Many of them have been discovered, but I'll talk you through one of the more famous ones in just a second. Typo squatting is very common. You pull down a package, and unbeknownst to you, there's a package with a similar name expecting a typo. And if you were to type that, it would trigger an exploit and make your system vulnerable. While not common, malicious source code injection is actually the area that creates the most angst for defenders. Examples range from stealing credentials from project maintainers, and so you can slip malicious packages into popular packages, releasing new versions into a public repository that actually are not legitimate, and then faking the pull requests to that project, making it popular and seem like the official one, tampering with open source developer tools like CodeDev, and the most famous one being SolarWinds, where a security vendor was compromised, and then their patch management system was used as a way to inject malicious code through the patching process into around 15,000 systems. The other trend is, not only is it growing, it's actually accelerating, in the sense of the speed of attacks is increasing and remediation windows are shrinking. For example, the window between a POC being released and seen in the wild has shrunk down to hours. The Atlassian POC, which created a lot of grief, it was announced, and the patch was actually announced more or less at the same time, but a number of compromises took place because there was that gap between bad actors realizing there was a proof of concept and folks' ability to patch systems. And a fair number of these exploits take place over long weekends and things like that, where security teams are undermanned, understaffed, and so forth. What is very interesting was this study that on February the 9th, a academic researcher reduced a very well-known dependency confusion exploit, and literally within 24 hours, there were 300 copycat exploits already in motion, and within 30 days, it had been totally institutionalized with around 10,000 of those. And that's obviously really tough for us as security practitioners, because again, it means we've got all these components, all these patches, and if we happen to miss one, then we're vulnerable. So there is a whole host of topics that could be included in software supply chain risk, but we're going to focus on containers, mainly because it's an area of high concern for security teams. The usage is growing. There's considerable certification pressure for businesses to certify their containers, both from a vendor perspective and a compliance perspective, and things of that nature. But at the end of the day, the challenge here is another example of just more components being out there in essentially our delivery chain. 16% of companies use containers in 2019, and 65 are expected to use them in 2023. And that creates issues for us in the sense that your average application has 8 to 12 containers. Again, there's this recurring theme of more components, more problems. And within each container, there's an average of around 120 vulnerabilities. And open source technologies are moving fast. Your average application has 128 dependencies, and these open source projects are updated every 6 weeks, which is a very frequent release cycle. And of course, that then prompts an entire wave of patching and upgrades and so forth. So not only is this problem receiving a lot of tension in security circles, the federal response to it has been pretty unanimous in that practically all the major industries have released initiatives around container security and things of that nature. And the most telling one being the recent presidential executive order, and there was an entire paragraph around scanning and things of that nature that I'm going to get into. So what to do about this? Well, there's a number of techniques that various practitioners are adopting. One of the most common is creating base images or golden images, and restricting what can be bought into your infrastructure through whitelisting and so forth. The challenge there is that because things are moving so fast and these things have to be manually created and so forth, it's very easy to get out of date and out of sync and for a backlog to develop. Software components analysis scanning, which we're going to get into in quite a lot of detail, followed by manual vulnerability removal, is probably the most common technique, and is actually delivering a fair amount of success. And the idea here is you scan all of your artifacts, you know more or less what's in them, you can then prioritize the risks and manually remediate them. And there's a variety of other techniques ranging from static analysis and so forth, putting policy agents on the containers to examine them and see if they're doing anything that violates any of your policies, instrumenting the containers, as well as container slimming and attack surface reduction, which is slimming these containers down quite dramatically. And we're going to talk about the benefits and challenges of doing that. But by way of reference, here's a standard Nginx container that you would pull down from Docker Hub. The US Air Force is one of the leading agencies in the Department of Defense, and they have a combination of golden images and SCA scanning, and you can see the vulnerability profile there, and then there are opportunities to dramatically improve upon that. So what are software component analysis scanners? Well, basically they're pieces of software that get a list of the packages or the artifacts in any given build, and then they do that from examining files and metadata in the application. So the scanner goes in and it says, okay, what exactly is in this file structure? And then it cross-references it with a vulnerability database, and so that you get a list of the results. And so you can see that this software package had this package installed, and this was the vulnerability. And that's essentially all it is. It's a packet analyzer along with some logic around cross-referencing it with vulnerabilities. So when you start thinking about scanners and you want to evaluate effectiveness, accuracy in terms of how many packets they detect, and along with the associated vulnerabilities is important. The scan depth, what are you scanning? Are you scanning the app, the open source components, the operating system? What exactly is your system looking into? And there's a big push to expand the scan depth to beyond the standard components that the traditional ones are using today. Vulnerability database quality is obviously a very important thing. And this is where a lot of the market participants separate themselves, and they say, we have proprietary databases, we know about vulnerabilities that you don't, and so if you partner with us, we'll give you the advantage of our database being fresh and timely and things of that nature. And then the other consideration is coverage. You just want to have one scanner for essentially your entire workloads, and so you need to make sure it covers all the programming languages, OS variants, and things like that. So only 40% of companies are using scanners at the moment. However, the interest is growing on them very significantly, and it's becoming an extremely hot topic, which is one of the reasons we wanted to talk to you about it tonight and to demonstrate it. So a related concept to a vulnerability scan is a software bill of materials, whereby all your artifacts are listed, and not only that, the license, which organization created them, who was the creator, and so forth. And so this inventory essentially gives you some views into your components, and then this is done at a variety of times during the build process. Typically, where we see scanning being deployed is after containerization has occurred. The devs will do a policy scan in engineering just to weed out any vulnerabilities. It usually goes to a security team, and then after it's actually put in production, these containers continue to be scanned. And the reason for that is vulnerability profiles change. There's changes in the severity as new information comes to bear. As proof of concepts get into the market, it becomes clearer. The nature of them becomes clearer, and new ones are being discovered all the time. And so scanning essentially needs to take place at all the points in your delivery cycle. So when evaluating scanners, I'd recommend reading both Gartner and Forrester. There's free reports, and both of them have what I think are pretty realistic assessments of some of the leading scanners. And again, you're looking at the ability to identify packages, the quality of the database, the quality of the vulnerability identification. A lot of these scanners have prioritization and risk ranking, so they have proprietary algorithms to determine which vulnerabilities you should work on, and they're typically integrated into CI/CD workflows automatically, and so builds can fail or pass and things like that. And they typically have centralized dashboard reporting, and so the quality of scanners is good, and it's actually a very competitive marketplace. And I'd be happy to tell you about our experiences with any of them. But the differentiated features are really around database quality, custom patches, and things of that nature. And like any segment of the market, there's a lot of hype in terms of how vendors are trying to position themselves and so forth. I do have a list of any of the scanners. I'm familiar with quite a few of them. So if you want to chat about any scanners or considering a commercial scanner, please consider us a resource. That being said, there are 3 popular and very good open source scanners, and we're going to profile those for you today and show you how you use them and things of that nature. And again, we do use these. We like them for a variety of reasons, and we actually have our own scanner as well, which would be delighted to offer to any member of the ISSA free of charge, and so forth. And so if you want a scanner and you're interested in scanning, please consider us an ally in that. So the problem with scanners is quite deep-seated in that they identify some of the risks and not all of the risks. And that's really going to be the topic of Rajiv's talk, in that it's possible for you to have code and infrastructure that passes some of these deep scans while it's still being extremely vulnerable. Before we do that, Rajiv, if you could just give the group some live examples of scanning with these various tools and indicate what you're doing, why they work, and how to use them. That'd be great. Thank you very much.
Yeah. Thank you, Russ. Can you give me the share? Oh, sure.
Sure. You've got it?
Yeah. Do you see my screen?
Yes.
Do you see my screen? Okay, thank you. Thank you, Russ, Mike, and Ed. It's my pleasure to be here. A little background of myself. I jumped into cybersecurity 5 years ago with the one startup that was basically doing threat intelligence sharing, and it didn't fly. Then I went to another startup, Color Tokens, where we did lots of zero trust related work. Then I moved to Palo Alto, where I scaled their subscription service. And eventually I went to Safe Security, which was bought by F5. And we were doing credential stuffing there. So one of the things in common about all these companies was basically is that principle of least privilege. In cybersecurity world, I find this is the most powerful terminology that pretty much everywhere it used. I had a very simplistic view of cybersecurity. Hey, we have a two-factor authentication. We never allow anybody to log in using password. You have to always use SSH key, a strong key, and everything. But then at Palo Alto, what I saw is that things can be hacked so easily. And one of the things that people do not look very carefully is the software. Eventually, it's the software that gets compromised. And what I was very surprised is that people are shipping code that has so much privilege, but nobody is basically have a solution around it. And that's where the idea of Rapid4 actually came from. So the basic premise for Rapid4 is very simple. If you are shipping unused code, you are violating principle of least privilege. And I'm going to show you in a demo also. But before I go there, so let's take an example of the latest tool like Gripe and Trivi, how they scan your code. So let me share my screen. So I've got a container image. And I'm going to use Gripe to basically scan this one. What it does is basically looks at the details of this container image. It finds 42 packages, and out of these 42 packages, it found 9 vulnerabilities. Now, I took an example of Alpine. Alpine is supposed to be the most minimized version. That means it has pretty much very small component. It actually has only one binary, and the rest of the stuff is just basically supporting it. It's a very optimized container. But even if this optimized container, it does have some vulnerabilities. And this is the latest and greatest code that is released by the Nginx team 12 days ago. As Russ was mentioning, as these packages, these vulnerabilities are actually cross-referencing them with a niche database where somebody had tagged, hey, this kind of package has this kind of vulnerabilities. I was trying to install Trivi, but somehow it did not work out for me, but I will still give it one more try, but I don't want to bomb this demo. Let's give it, okay. So yeah, Trivi also finds the similarly thing. It finds that it has, it doesn't give me the package. It says basically it has 6 vulnerabilities right now. Okay. We are not going to do Rapid4. Rapid4 we are going to do in the end because we have a very powerful scanner. So at this time, I'm going to show you a simple demo of this product actually. So I use latest and greatest Nginx emails to create my own website, create my own React application. So what I did as a developer is I took an Nginx image, I installed Bash because Bash helps me write scripts, lets me debug and play with the system. So I just took that one. Let's build this application. Let's call it web app. So now we will have 2 Docker images. So we got 2 Docker images. Let's run this Docker image. Okay. Okay. Before I do that, me get the IP address. Okay. Let's run our most famous port, and let's put this application in the background. So if I go take this IP address in my browser, I'm serving some web content here. Now, while this application is running, some hacker is watching it somehow. And what I'm going to do here is that I'm going to do some remote execution of the code. So I'm running this one. You will see something is going to happen on the bottom when I run a simple command. So here, the hacker basically just got the complete access of your container. And now, if I want to do what malicious thing I have intended, I can do here. So if I refresh this page, yeah, the system is compromised. Okay, so this is all happened because the developer left the bash command there, and bash has a known vulnerability. You can basically just hack the whole TCP port there, and any activity that happens, somebody can basically get that one. So imagine you put your Nginx as internet facing, which basically terminates your certificate. After that, everything is vanilla text. If you have this kind of system and if somebody has got the access to this one, you can pretty much see who is logging, what their credentials and everything. Okay, so what we are going to do here is that how Rapid4 basically prevents this problem is that we are going to before we go that. So that's basically the compromised system. So what Rapid4 does is basically within a minute, basically it takes your container, profiles its runtime behavior, and what you use it stays there. What you don't is throw away, and that's how we basically create a container that basically fits your requirement. At the same time, it has nothing left. So you have very smaller container which basically loads faster. It basically less footprint on your artifactories and all. And one of the most valuable thing that reducing the size brings is basically you have less vulnerabilities, known vulnerabilities and unknown vulnerabilities. As you saw that nobody was complaining about that you have a bash and then it can be hacked even if there is no vulnerabilities floating around that one. That's what basically your zero-day attack. Third thing is a patch management. So a normal container has from 100 to 200 packages when you containerize them. If there is a fix available, you have to patch them. Imagine if you have hundreds of containers in the company, how gigantic this task is. It's almost not easy to basically manage them. It requires testing. It requires a lots of moving pieces here and there. One of the strangest thing I have seen in the software development is that companies spend lots of time creating a CI/CD pipeline. The purpose is you write your software and you frequently deliver it to your customer or bring the business value out of it. Security is always an afterthought. Don't worry about that one. Let's fix the algorithm. Let's solve the scaling challenges, and then we'll take care of the security. What happens is that time you basically make lots of architectural decisions. You cannot basically you can revert if you have written a bunch of code and it depends on certain packages. You cannot make that decision in the end. So the first thing that the problem happens is that you have broken the CI/CD. You do all the software release process in a frequent manner. Everything is automated, the test and everything. But when it comes to security, you bring another team that basically works with developers and PM, and then you try to remediate that. So all your effort to make this CI/CD basically just falls flat when it comes to security. Again, you have less packages. That means you have less, security issues. You have less basically compliance and license issues. While working with a Rapid4, one of the most fascinating thing we found is that the enterprise applications, pretty much 50 to 90% software is not being actually used. They're just sitting there, and sitting there, it can be exploited, as you just saw that in the demo, that BAS is not required to run my web application, but you're putting there. And now somebody can just hack it and then basically do whatever they want to do it. The last image is basically what Rapid4 does, is hardening as a service. We basically plug in your CI/CD pipeline very easily. When the developer writes a code, they check in their code. The typical release cycle is like this. You build it, you test it, and you release it. Where we come in the picture is that when you build it, you call a Rapid4 utility called a stub, RF stub, which takes your application, and in return, it gives you a new Docker image. That Docker image has a capability to profile it. Now, when you test it, you don't test your original application. You actually test the sub application that we have given you. And it is very agnostic of wherever you deploy it. You can deploy in Kubernetes, you can deploy in Docker Compose or Fargate, wherever you deploy it. The moment it gets alive, the tracing and profiling starts. And after few hours, few minutes, manual testing, integration testing, coverage testing, whatever test you do, you just signal Rapid4 that, hey, I'm done whatever I wanted from this application. You signal us, we run another command called RF harden. We take your image, in return, we give you a hardened image. Now, this hardened image, as you see in the bottom here, we did the POC with the USAP. We saw that there is 80% reduction in the size and 80% reduction in the vulnerabilities. And we are going to demo you here also. Okay. So same hacking we are going to do here. So we have a Docker image. We take this image and at that time, what's happening is we are taking your container, we are pushing it to Rapid4 infrastructure. Rapid4 basically tries to understand what is the composition of this application and injects the tracing module into it. It does lots of security stuff, like it does the vulnerability scan, the packages scanning. It does some rapid risk score also. In the end, it gives you basically a estimation also. If you harden this kind of application, we have seen close to 81% reduction in the attack surface, and number of packages goes by 77%, and the number of vulnerability also goes to 77%. So now if I go here, what we see here is that Rapid4 has given a new container image. Now we run this application. You have to give us one extra capabilities. So that we can do the tracing. I'm just going to remove this one so that I can close it here. Okay. How to stop this? Sorry about that. So the application is running. So I'm profiling this application right now. I'm not going to compromise it during the profile time. That will defeat the purpose of demo. So yes, we did this profiling of this application. And now we tell Rapid4 that I'm done testing my application, give me my hardened image. So that's the last command you use, rf harden. Now what it does is that it has created the profile of your application, the network activity, and all those things that you did during the testing. And it basically, now if I do here, you see that it has given you a third Docker image, which is very small in size. The vulnerabilities, we were lucky, none of the component you are using is left with any vulnerabilities. So all the vulnerabilities are gone. Size also reduced significantly. Now let's see whether even this works. And we are going to hack this guy also. So now at this time, you're not going to run this one. You're going to harden. We don't need any more. At this point, the container you have been given, Rapid4 is out of here. There is no agent or anything running there. So we don't need this one. And I'm going to put in the background so that I can try to hack it. Okay. Yeah, so let's see if the hardened image is working. Yeah, it's running. Now let's try to hack this one. Okay. Docker. Okay, and we are going to run this one. Okay, first hacker, you start listening. Oh, the bash is not there. So what you see here is because this bash is not required in your production deployment, what's the point of shipping it? And that's what Rapid4 is basically saying, that if you are shipping unused code, you're basically violating the principle of least privilege. Okay. Thank you, and that's it. What do you ask?
Mark would be delighted to take any questions on any of the scanning and in the industry stuff, any of the example.
Thank you.
Sure.
That was really great. And actually have one